everyone. Please, if you are active, indicate that you are active. If you are active, please indicate that you are active. I hope you are all hearing me. Please, if you are active, indicate that you are active. If you are active, please indicate. We are waiting for others to join us. Please, if you are online, please indicate that you're online, that you are active. If you are active, please indicate that you are active, so we can start. Please indicate that you're active. Is the board clear? Can we proceed now? Can we proceed? Okay, we have 5 people online. Let's wait for others to join us so we can proceed. All right, we are starting very soon. We are starting now. Please, let's keep on sharing the group link to others. Let's keep on sharing the group link to others. Please, if you have joined, just share the group link to others, please. Share the group link to others. Keep on sharing, keep on sharing. Let's share the group link to others. Okay, we are starting now. All right, let's start with what is set theory. Then we'll look at mapping function. Okay, in today's class, we shall be connecting two topics together, which are set theory and mapping functions. All right, because the extension of map of set theory is actually mapping function. Is mapping function. So, what is set theory? We all know the basic on this topic. We know that set theory means a collection of well-defined objects. Set rather is a collection of well-defined objects. When you hear the word set, it means a collection of well-defined objects. That means there are two things that define a set. One, there must be a collection. Number two, the collection must be of a well-defined object. The object must be well-defined, right? For example, every online student, let's say, you are a collection of EMI-BRAIN online students. So this is a set. Nigeria is a set because it's well defined that every occupant of Nigeria or every members of Nigeria are well defined to be Nigerians, right? So when you hear the word set, set means a collection. When there's a collection of well-defined objects, that means a set. And set can be represented with a symbol, this. This is the symbol for representing a set, not brackets, but a coil bracket of this kind. Okay, this is how we represent sets. And sets are also represented with an alphabet, okay? With an alphabet, with a capital letter representing an alphabet, like capital letter A or capital letter what? B. We don't use small letter to represent a set, but we use small letter to represent elements of what of a set. But generally, we use capital letter to represent a set. We can have a set of set A representing maybe a set of all even numbers or a set of all alphabets. Either we can have B to represent a set of all odd numbers, etc. and all that. So I'm going to define what set is. The set is a collection of well-defined objects. Now, we have two ways of representing a set. There are two ways of representing a set. The first way is what we call the roster or the tabular method. The roster, also called the tabular method. We have two ways of representing a set, the roster method or the tabular method. Number two is called using the set builder. The set builders. The set what? Builders, all right? Or set notation. We call it set builders or set notation. The roster or tabular method is one you all know. Under the roster, for the roster method, let's say we can represent A to be a set of numbers like 1, 2, 3, 4, 5, right? Or we can represent B as a set of alphabets A, B, C, D, down to Z, right? We call it what? Roster or tabular what method. Then using sets for set builders represents using what we call set notations. Like for example, let's say set A represents X such that X is an even number less than 10. Okay? S is such that S is an even number less than 10, meaning all the even numbers, but less than what? 10. Meaning 2, 4, 6, and what? And 8. Right? So we call this set builders. We call it what? We call this method roster or tabular method. Okay. Now let's move on to what we call types of sets. There are different types of sets. The first one we'll look at today is called empty sets. Please, if you're online, indicate that you're online and let's keep on sharing the group link to others. I will try and summarize sets that will solve some problems in your past questions. We'll look at some calculations or problems or word problems This class will be extended to Venn diagrams involving 2 subsets, 3 subsets, either, and how to interpret Venn diagrams. All right? All of this class is what we shall be considering today. Then at the end of this class, we also extend our learning to mapping function. But we'll look at co-domain and domain, range, and all that. All right? So please, if you have shared this, keep on sharing, keep on sharing, keep on sharing. Invite your friends in other departments. This is our Mathematics 101 class. All right? So let's proceed. Now, we have seen that we have 2 ways of representing sets. We have the roster method, also called the tabular method. Then we have the set builders, right? Which is also known as the set notations. Like we saw that A is a set of X elements so that X is an even number less than what, 10. All right? Okay. So let's look at the various types of sets. The various types of sets. There are various types of sets. Types of sets. Types of sets. Number 1, we have what we call empty sets. Empty sets. When I say empty set, a set is empty if that set has no elements. Any set that has no elements is called what? An empty set, right? It's called an empty set. It's also called a null set. A null set. So the symbol for an empty set is either this, or we use a symbol like this. This means an empty set because there's no element found in this set, right? Or we can use a null set or a null symbol. This is also called an empty set. So empty set means a set that has no elements in it, right? Number 2, we have what we call equal sets. Equal sets. Now, when I say equal set, 2 sets are said to be equal if they have the same elements. If they have the same element, that means all the elements that are found in set A are also found in what? In set B. For example, if set A is given as 2, 3, and 4, and set B is given as 3, 4, and 2. When you look at these 2 sets, you'll find out that both set A and set B have the same elements. We have 2 in set A, we have 2 in set B, we have 3 in set A, we have 3 in set B, we have 4 in set A, we have 4 in set B. That means that set A is equal to what? Set B. It means that set A is equal to set B. So 2 sets are said to be equal if they have the same elements. All right? If they have the same elements. Okay. Now the next type of set we look at now is called equivalent sets. The third one, equivalent sets. Equivalent sets. Now, when you do what equivalent sets, it simply means that 2 sets are equivalent if they have the same number of elements. If they have the same number of elements, meaning if they have the same cardinality. If the number of elements in set A is the same as that of set B, we can say that set A and set B are what? Equivalent to each other. Okay? Don't forget that the symbol for equal set is this, right? But if we have this kind of symbol, this is called what? Equivalent. So if set A is equivalent to what? Set B, that means both set A and set B have the same number of elements. That is, it simply means that number of elements in set A is equal to number of elements in what? Set B. Regardless of the types of elements they contain, even though they do not contain the same elements, or they don't have any intersection or anything in common, as long as the number of elements in set A and set B are the same, that means they are equivalent, but they must not be equal. Equal sets can be equivalent, but not all, or how will I put this? Equivalent sets are not always equal, but equal sets are what? Equivalent, right? For example now, if set A is 2, 3, 4, and set B is 3, 4, 2. That means set A and B are equal. Also, set A and B are also equivalent because they have the same number of elements, right? Okay, let's look at a good example under equivalent. If set A is left, say we have 1, 2, 3, and 4, and set B is 1, 4, 6, and 8. Okay, if you look at this, the number of elements in A is 4. That of B is also 4. That means that set A is equivalent to what? Set B. Although, but set A is not equal to what? To B. Don't forget that set A is equivalent to set B, but set A is not equal to set B. Why do you say set A and B are equivalent? Because they have the same number of elements. The number of elements we have here is 4. This is also what? 4. But the elements that are found in A are not the same elements that are found in B. So we cannot say that set A and B are equal, but they are not equal. It means that set A is not equal to set B. But in this example here, A is 2, 3, 4. B is what? 3, 4, 2. That implies that set A is equal to set B. Also, set A is also equivalent to what? To set B. Either. Now let's move on to the next type of set. Please, if you're online, just indicate that you're online. If you're active, please indicate that you are active. If you are following, please indicate that you are following. Please help me to share this group link to others. I want many people to benefit. There's a lot to learn here. There's a lot to learn. You might think you know set, but I will prove it to you that there's some knowledge you might not be able to comprehend. By the time we start looking at proofs in set theory, we start solving some past questions, you will appreciate this class, right? So many students have been making the set about equal set and what? Equivalent set. Now I've been able to differentiate them, right? That equal set means they have the same elements in common, all right? But when you hear the word equivalent, that means they have the same number of what? Of elements. If you are following, just say it, I am following. Please, if you are active, indicate that you are active. Please indicate. Don't just come online and be watching. Indicate that you are active and share the group link. If you have shared the group link, say I have shared it. Please, let's be active. Let's be active. Please share. If you have shared, just say I've shared the group link. Just share. Now the next one is called the Singleton. The Singleton Set. The Singleton Set. The Singleton Set. Now the Singleton Set, when you hear the word Singleton, this is a set that has just one element. A set with one element is called what? A singleton. For example, if set A is just only 2, that means set A is called what? Is a singleton, right? It's a singleton. If set A is just only 2, that means set A is a singleton. The next one we'll look at is called what we call subsets. We have what we call subsets. And number one, we look at subsets. Also look at what we call proper subsets. Proper subsets. I will explain these two together. A lot of people are having difficulties in differentiating between subsets and proper subsets. Subset and proper subsets. Now, when I say subsets, their subset simply means part of another set. If A is a subset of B, that means every element in A, okay, are found in what? In B. Are you there? If A is a subset of B, that means that every element in A are found in what? In B. Subset means part of a given set or part of a general set. For example, now, if I have Imo State and I have Nigeria, that means Imo State rather, is a subset of what? Of Nigeria. Then Nigeria become a superset to what? To Imo State. Superset simply means a set that contains the subset. It's called a superset. So like I explained, I use Nigeria and Imo State. But let me explain again. When you hear the word subset, subset means a part of another set. So if A is a subset of B, that means B is a superset of A. Now listen, the symbol for subset is simply this. And I will differentiate them together. Then when you hear the word proper subsets, both of them have the same definition. They have the same definition, sorry. We have the proper subsets. The symbol for this is this. Many students always confuse themselves. I've seen many students come to me and say, which of these symbols represents a subset? When you see any symbol like this represents a subset. This represents what? A proper subset. Listen, if A, let's start with this first, subset. If A is a subset of B, this implies that either A is equals to B or A is not equals to what? To B. I will explain. If A is a subset of B, meaning every element in A are in B, right? Then most at times, A is always equals to B, or what? A is not equals to B. Why do we say so? In mathematics, if we have this sign means what? Equal, right? If I have this sign, this means greater than. If I have this sign attached to it, it means greater than or equals to. So this sign you are seeing here is a sign of what? Equality. So I'm saying that if A is a subset of B, first is that A, this sign means equal. Don't forget, this means greater than or equal to. Listen, if I say A is greater than or equal to B, this implies that either A is greater than B or A is equal to what? To B. I hope you are aware. If A is a subset of B with this symbol, this means what? That A is equals to B or A is not equals to B. A good example is this. Let's say we have subset A to be equals to 2, 3, 4, and subset B to be equals to what? Let's say 2, 4. Let me come this way. 4, 3, and what? And 2. What do you notice here? You will find out that every element in A are also in B, although A and B are equal, right? A is equals to B. That means since every element in A are also found in B, that means that A is a subset of what? Of B. Since every element in A are in B, also every element in B are in what? Are in A. Subset is a two-sided thing. If A is equals to what? To B, B must be equals to what? To A. That is a subset. For this sign means equality. So if A equals to B, that means B equals to A. So one of the conditions for subset is that A must be equal to what to B, or A is not equal to what to B. In another example, let's say if I have subset C rather, and subset C, let me use the word D. Subset D is 2, 3, 4, and 8. Or let's say 5. 2, 3, 4, 5. What do you notice here? Every element in A are in what? Are in D. But A is not equal to what to D. Don't forget that we have two conditions for subsets. What the first condition is either A is equal to B or A is not equal to what to B. Am I communicating now? So I can say comfortably that A is a subset of D. But in this case, A is not equal to D. Right? I can also say that B is a subset of D. Do you know why? Every element in what? In B are in what? And in D. Although they are not equal. Do you get the concept now? But for these two, A is also a subset of what? Of B. Now, what then is proper subset? Look at this. For proper subsets, the symbol is C, abi? Just this curve. If A is a proper subset of B, since there is no equal sign here, it means the proper subset has only one correlation. What is the condition? Is that A is not equal to what? To B. That implies that between this and this, I can also say that A is a proper subset of what? Of D. Reason because the value of A is not equal to what? To B. The reason why I have to start with equal set, so I can understand what equal set is all about. That two sets are equal, right? If they have the same elements. A and D don't have the same elements, but every element in A are what? Are in D. That implies that A is a proper subset of B because A is not equal to B. So that means that both subsets and proper subsets have similar definition. The general definition of both of them is that every element of the given set must be found in what? In the other set. Both definition. But to distinguish them is from their equality that in subsets, A must be equal to B or A is not equal to B. But for this year, A is only equal to B. Now let me ask this question. Can I say, since A is 2, 3, 4 and B is 4, 3, 2, can I say that A is a proper subset of B? Can I say A is a proper subset of B? No. Reason because the condition for proper subset is that A is not equal to B. So what I'm saying here is that, let me just bring out the definitions. So I'm saying here that A is a subset of B, right? B is also a subset of what? Of A, right? Because for both of them, both A and B are what? Are the same. Now, this also implies that A is a subset of D. Why do we say A is a subset of D? Because subset has two conditions, A equals to B or A not equals to B, right? Then I can also say that the same B is a subset of what? Of D. And let's go. But A is not a proper subset of B. Is not a proper subset of B. Why did we say it's not a proper subset of B? Because A is equal to what? To B, right? Are you following? A is not a proper subset of what? Of B. Yes. A is not a proper subset of B because the condition for proper subset is that A and B must be equal. But can we say that A is a proper subset of D? Of course, yes. A, set A is a proper subset of D because the condition for this is that A is not equal to what? D. And it's true. If you look at A and D, they are not equal sets. So that means that A is a proper subset of D. Am I communicating? Now let's move on to the next one. Please, if you are following, say I'm following. The next one is supersets and super proper sets. I won't spend much on this. If A is a subset of B, this also implies that B is a superset of what? Of A. Superset is the reverse of this. If this is proper, if this is what? Subset, it becomes what? A superset. This is subset. This means what? A superset. A superset simply means a set that contains every element in the word in A. If B is a superset of A, that means every element in A are found where? In B. Do you get the concept? Now, for that of super proper sets, let me explain. If A is a proper set of B, that implies that B is a super proper set of what? Of A. If A is a proper set of B, that means that B is a super proper set of what? Of A. Just like that. There's nothing much about this, okay? But just take note of this symbol. That this symbol means what? Super what? Super proper sets. This means super proper sets. Okay? This means what? Super sets. Now let's move on. The next one I want us to look at is called disjoint sets. Disjoint. When you hear the word disjoint sets, two sets are said to be disjoint if they have no element in common. Meaning if their intersection is equal to 0, they are called what? A disjoint set. For example, if set A is given as 2, 3, 4, and set B is given as 5, 7, 8. That means our A intersection B is an empty set. Therefore, set A and set B, set A and set B are what? Disjoint. They are disjoint what? Sets. If A is 2, 3, 4, B is 5, 7, 8, it means that A intersection B is what? Is empty. There's nothing common between A and B. Since there's nothing common between A and B, that implies that set A and B are what? Disjoints. They are called disjoint what? Sets. They are called disjoint sets. Okay, so let's move on. The next one we'll look at is finite sets. Then we'll look at other aspects. Finite or finite set, right? Finite sets. These are sets with limited elements. Limited what? Elements. These are sets with limited elements. Okay, infinite sets. These are sets with unlimited elements. Unlimited what? Elements. Okay, a good example, if A is represented like this, let's say 2, 4, 6, 8, and 10. Here we have a finite set because we have a limited elements. But if I have set B to be 2, 4, 6, 8, 10, then we have dots at the end of this 10. This means what? Infinite sets. Okay? Are you there? So any set that has a limited element is called what? A finite set. Another example we can give for this is if we are saying that using set builders, right? That X is such that X is an even number less than 10. This is also a finite set because I can interpret this number, this set as what are the even number less than 10? There are 2, 4, 6, and what? And 2, 4, 6, and what? And 8, right? This is the interpretation of this. So this is called a finite set. But if we are told that A is such that X is an even number, S is an even number. This simply implies set A is what? 2, 4, 6, 8, 10, 12, dot, dot, dot. We can exhaust. That means to infinity. Okay? So the word infinity is same as the word infinite. It has no end. The numbers here are what? Unlimited. Okay? So that is just that. And let's go into other aspects of set I want us to talk about. Then we'll solve your past questions. Other aspect of set. The last one we'll look at now is called the universal set, right? Universal set. This is a set that contains every other subset. It's a set that houses every other subset. The symbol for this is most of the time given as this, right? The symbol for universal set is just a curved U. Okay? A set that contains what? All subsets. All subsets. It's called a universal set. Like Nigeria is a universal set because in Nigeria we have other subsets like other states. Other states represent what? Subset, part of the general set are called subsets, right? So Nigeria is a good example of a universal set. If we should pick a given, let's say a particular state in Nigeria, let's say Imo State. Imo State can also represent a general set because in Imo State we have various local governments, just like that. So every set that houses every other subset under discussion is called what? A universal what? Set. Now, the other aspect I want to look at is called the properties of sets. What are the properties of sets? The properties of sets. The properties of sets. Number one, we have intersection of sets. Intersection. of sets. Number 2, we have union of sets. Number 3, we have cardinality of sets. Okay. Number 4, we have set difference. Number 5, we have complement of sets. etc. I will briefly explain this, then we can proceed. I won't talk much on this. I will just explain, then we can proceed. Now, when you hear the word intersection, two sets are said to be intersected with each other if they have common elements, if they have any elements in common. For example, if I have set A to be 1, 2, 3, 4, and 5, and set B is 2, 4, 6, and 8, that implies that A intersection B is given as between A and B. What is common is what? 2 and 4 is 2 and what? And 4. That implies that A intersection B is 2 and 4. So the symbol for intersection is simply what? N. A small letter N. Okay? This is called what? Intersection of sets. Alright? But don't forget that when there is no intersection between two sets, those two sets becomes what? A disjoint set. Right? We have already explained what is disjoint. The disjoint means when two sets have no elements in common, that means they are called disjoint sets. Now the next one is called union of a set. Union means combination or combining two or more sets without repeating any element, okay? Without repeating what? Any element. For instance, if I have A and B, and I'm to find A union B, the symbol for union is just a curve U, okay, of this shape. When you invert this N, we form what? Union, either, or U, rather. A small letter U, all right? So here we have A union B. Combination of these two sets without repeating any element is called union of sets. And let's watch. We have the first element we have is 1, right? Followed by what? 2, followed by what? 3, followed by what? 4, followed by what? 5, followed by what? 6, followed by, there's no 7, but we have what? 8. This is called union. A union B equals to what? To this. Union means I'm combining, but without repeating any element. If you notice, we have 2 and 2 here, repeated both in A and B. We only pick one of them, right? That's called union of a set. The next one means we have is what? Cardinality of a set. Cardinality of a set. Now, I've already explained what is called cardinality of a set. Cardinality simply means the number of elements in a given set. Cardinality of A, of set A. The symbol is what? Number of elements in A. In A. Okay? Number of elements in A. If you look at this, set A is 1, 2, 3, 4, 5. Set B is what? 2, 4, 6, and 8. And if you are asked to find the number of elements of A, how many elements can we get in A? 1, 2, 3, 4, 5. The answer is what? 5. Elements of a set are those things that are contained in a given set. These are those things that are found in a set. How many are there here? There are 5 in number. But for that of B, number of elements in B is simply 1, 2, 3, and 4. The answer is 4, right? What if we also find number of elements in A union B? Number of elements in A union B. Meaning, in their union, how many elements do we have here? We have 1, 2, 3, 4, 5, 6, and 7. The answer here is what? Is 7. Number of elements in the union is what? Is 7. Right? So let's proceed to something else. The next one is called set difference. Set difference. Set difference. Set difference. I won't talk much on this, but just take note that when you hear the word set different, it's like saying every element that are found in a given set that are not in the other set. That's called a set different. For instance, now, the symbol for representing set different between two sets, A and B, is either this. Okay? When you see something of this in sets, this means A difference B. It can also be represented as A slash what? B. Okay? So this means A difference B or A difference B. Okay? If I have this, the whole of this, these two things, yeah, can also be represented as A intersection B complements. Okay? A intersection of what? B complements. After this, I'm going to explain what is complement of a set. Although some of you already know this already, but just take note that A difference B can also be represented as what? A slash B or A intersection with B complement. Then if I have B difference A, this is also what? B slash A. Then this can also be represented as what? B intersection what? A what? Complement. Don't forget. Okay? A complement. So this is what we call set what? Difference. Now let's look at a good example on set difference. A good example on set difference. A good example under set difference. Let me use this example we have here just to solve. Okay, let me extend this to 6, 7, 8, 9, and 10. Let's say if set A. Okay, let me reduce. Let's remove 9 and 10. All right. Okay, if set A are elements, are set of elements from 1 to 8, right? Then set B are elements, even numbers, right? 2, 4, 6, and 8. And we also find A difference, what? B. Okay? What is A difference B? B is same as what? A slash what? B, right? A difference B means what are the elements that we can find in A that are not in B? Let's check them out. A difference B. Elements that are found in A but not in what? In B. With what are there? We have 1 in A but not in B. So the first element is 1 at B. We have 2 here, but here. We have 3 here, but it's not here, right? The answer is what? Is 3. Then we have 4. There is no 4. So we have 4, there is 4. We have 5 here, but there's no 5 here. Are you there? Then the next is what? 7. So this means elements that are found in A, but not in what? In B. Element found in A, but not in B. Just look at all these elements here. What are the elements you can find here, you can see here, but are not in B? They are simply what? 1, 3, 5, and what? And 7, right? Because 2, 4, 6, and 8 are all in B. So the answer is what? 1, 3, 5, and 7. What if we are asked to find B difference A? Meaning, what are the elements that are what? In B, but not in what? In A. Elements that are in B, but not in A. 2 and 4 are in B. They are also in what? In A. So I will not pick them, right? 6 is here, but also here. 8 is here, but not also here. That means the answer here is what? Is an empty set. We have what here? An empty what? Set. Element found in B, but not in A. There is no element that are in B that are not in what? In A. So the answer is what? Empty. But in this case here, element found in A that are not in A, but not in what? In B. Element found in A, but not in B is simply 1, 3, 5, and what? 7. Please, if you are following, please say, I am following. If you are following, please say, I am following. Please share the link, share the link, share the link. Let's share the link to other people to join. Let's keep on sharing the link. Let's keep on sharing the link for others to join. Let's share, let's share, let's share, let's share. Sorry. Now the next one I want us to look at is what we call power sets. Okay. Now after this, we go into complement, right? Set complement. Now power sets of a given set, okay, shows us or it tells us how many subsets are found in that given set. All right. Power set tells us how many subsets that are contained in a given set. So power sets of set A, power set of set A is represented as P of A, which is equals to 2 raised to power n, where n represents the cardinality of A. For example, if we are given that set A is 2, 3, 2, 3, and what? And 4. Find the power sets of A. Solution to this, our P of A, the formula says what? 2 raised to power n. Power set tells us how many subsets are contained in a given set. And you must have to take note that the first subset of any given set is what? Is an empty set. The first subset of every given set is what? An empty set or a null set. The first subset of any given set is an empty set. So we are given that set A is 2, 3, 4. And we have to find the power set of what? Of A. Formula says P of A equals what? 2 raised to power n. Yeah, our n is equals to what? 3. N means cardinality of a set of A. The number of elements that are found in A is what? 1, 2, and 3. So that means that our P of A is simply 2 raised to power 3, which is equals to what here? 8. That means here we have how many subsets? 8 what? 8 subsets. Now what we do is to list out all the subsets of A. The number of elements, number of subsets that are possible in A are how many? We have 8. But don't forget that I said the first subset of any given set is an empty set. So to list out all the subsets, we have the first one would be, okay, let me start from here. Let's list out all the sets. The first is going to be what? An empty set. That's the first one. The second subset will be subset 2. Subset 2. The third will be what? Subset 3. Followed by what? Subset 4. Now, what do you notice here? The first thing we need to do is to bring out all the singleton, all the single sets. We started by bringing out what first? Empty or null sets. Followed by the first 2. Second 3. The third is what? We have 4, right? The next is 4. Then after here we have exhausted all the single sets. We'll now proceed to what? 2 sets. Since we have 3 elements here, that means there's a possibility of us getting single sets, double set, and what? Triple sets. If I have 4 elements, it means we can bring out what? Single sets, double sets, triple sets, and 4 possible set, abi. So for this, we have single, single, single. Let me bring out the double set now. The double set we have is what? 2 and 3. Followed by what? 2 and what? 4. Followed by, we have got that 2, 3, 2, 4. What's the next one? 3 and 4. 3 and 4. Then followed by the 3 sets. Because I've exhausted all the single sets. We have 2, 3, 2, 4, 3, 4. Then the next one is to bring out what? 2, 3, 4. 2, 3, and what? And 4. Then I'll close the brackets. Let's count how many elements we have here. We have 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 possible subsets that are contained in subset what? A. But don't forget that the first subset of every given set is what? An empty set. Okay? All right, so let's proceed to the next. All right. The next one I want us to look at now is that we're going to solve some past questions. We'll solve some past questions and we'll look at some of your exercises in your textbook, okay? In your textbook. This question, let's look at the first example. The first question I want us to look at. Just bear with me. Let me bring it out. Okay, question says that if A is a set of positive integers defined as A equals x is such that x squared plus x minus 6 equals to 0. Find the value of x satisfying the solution. Okay. Here we are given a question here that says that if A rather is a set of all positive what? Integer. If A is a set of positive integers defined as A equals x is such that x squared plus x minus 6 equals to 0. Please, if you're online, indicate that you're online. If you are following, indicate that you are following. If you are following, indicate that you are following. If A is a set of positive integers defined as A equals to x, so that x squared plus x minus 6 equals to 0. Find the value of x satisfying the solution. Solution is this. What we are going to do here is to bring out this quadratic equation, right? And see how we can factorize it. But don't forget that they said find the value of x that must satisfy this solution. Are you there? And we are told that A is a set of positive integers. So at the end of the day, after factorizing this, we'll look out for all the positive integers that are found where in this expression, right? Let's see what we want to achieve at the end of the day. So let's bring out the equation. We are given the equation, right? Given the equation, which is what? S squared plus x minus 6 equals to what? 0. So what we're going to do here is to factorize, right? We factorize the equation. We factorize the equation. Now look at this now. I want to believe that we all know how to factorize, but I will still explain. I will explain that now for those of you who don't know how to factorize. What we need to do here is that we have how many terms here? We have 3 terms, right? We have the first term, second term, and the third term. What we need to do is to multiply the first term with this last term, meaning s squared times minus 6. That will give us minus 6 s squared, right? Is that not? S squared times minus 6 is what? Minus 6 s squared. Then if you look at this center term here, what do we have there? We have plus x. I will bring it out. Plus what? X. We multiply s squared by minus 6. That gives us what? Minus 6 s squared. Then I just have to bring out the center number or center term, which is what? Plus 6. Now what do? Is to look for 2 factors that when you multiply them, the result will be minus 6 s squared. But when you add them or subtract, the result must be plus x. I repeat again. Think of 2 numbers that when you multiply them, the result will be what? Minus 6 s squared. But when you add or subtract, the result must be plus x. There's this skill I always like using to explain this. If I have, since we have 6 here, right? Or minus 6, or bring out 6 rather. What can go in 6 is out. The first is what? Is 2, abi? 2 years what? Is 3. What can go in 3 again is what? Is 3. For this now, we can play along with these 2 numbers here, 2 and 3. Let's see how we can achieve this number here. So what we do is that if I'm to put minus 2 here, or minus 2x, and minus 3x, minus 2x times minus 3x will give us plus 6s squared. So that means the 2 numbers can never be minus 2x and what? Minus 3x. Don't forget that we are looking for 2 numbers that once we multiply them, the result must be what? Minus 6s squared. Then when you add them, the result must be what? Plus 6s squared. Since if we should multiply them, the result will give us minus 6s squared. That means one of those numbers must be positive, while the other must be what? Negative. Because negative times positive must give us what? Negative. So I can't have both of them to be negative, because the end result will give us what? Plus. Now let's try out this. What we have, let's say 2s, right? And minus 3x. 2x times minus 3x will give us what? Minus 6s squared. Right? But 2x plus minus 3x cannot give us plus x. We are looking for a number that when you multiply them, you must have minus 6s squared. But when you add or subtract, don't forget the result of the what? Plus x. The center number here. Sorry, the center number here. So I can use 2x and what? Minus 3x. Although their product gave us minus 6s squared, but their addition They not give us what? Plus x. So I can try, I will take again. Let's check this out. What we have minus 2x and what? And plus 3x. Let's check this out. Minus 2x times plus 3x is minus 6x squared. Minus 2x plus 3x give us what? Plus x. I hope you are aware. Minus 2x plus 3x is what? Plus x. But minus 2x times 3x is what? Minus 6x. So the two factors I'm looking for is this. Because their product gave us minus 6x squared. Then their sum also gave us what? Plus x. So that means that while factorizing, I will replace these two numbers, right? With what? With plus x. It means that in this expression here, I will replace this and this with what? Plus x. Because minus 2x plus 3x will give us what? Somebody plus x. So this simply means what? Let's go. Here we have x squared, right? Minus what? 2x plus 3x, right? I've replaced this now with this. What's the next number here? Minus 6. All equals to what? 0. Now the next is to evaluate further. When you evaluate further, between these two terms here, I can group this into 2. Then group this together. Between these two, what is common here is x. I'll bring that x as a common factor, then put my brackets here. If x is common, divide this x squared here by this x. What's remaining is what? Is x, right? If I'm to factor out x here, it means only one x is remaining in this bracket. And how do we get this x here? Just divide this x squared by this x. That will give us what? X. Now divide minus 2x. Divide minus 2x by this same x here. What do you have? Can x cancel x? We are left with what? Minus 2. Are you following, guys? Okay. So that at the end of the day, when you multiply this back, I will come back to this. Let's watch. What is x times x? X squared. What is x times minus 2? Minus 2x. Then we are done with this first term. This first and second term. The next is to factorize this. Between 3x and minus 6, what's common? Is plus what? Plus 3. Plus 3 is common between them, Abi. If plus 3 is common, divide this 3x you are seeing here with this 3. What is remaining here is what? It's x. Divide minus 6 with this other 3. What you have here is what? It's minus 2. All equals to what? 0. One of the ideas behind it is that anything you have in this first bracket must appear again in the second bracket. So I'm going to treat this as a single one value. Then also treat this as a single value. Then here becomes what? S plus 3 equals to what? 0. Then I'll pick one of these. What do you have? X minus 2 all equals to what? 0. Alright? Now the next is to find the value of x. When you move this 3 to the other side, here becomes what? S equals to what? Minus 3. Or for this, when you move this minus 2 to the other side, becomes what? S equals to what? 2. If A is a set of positive integers defined as this, find the value of x that satisfies the solution. So since A is a set of positive what? Integer. The value of x satisfying the solution is between these two values, which of them will satisfy the solution? If A is a set of positive integer, that means s equals to 2. Is simply A equals to what? Set what? Set 2. But if they say if A is a set of negative what integer, so that means I'm going to pick what? -3, right? Because -3 is a set of what? Negative integer. So put this down before we go into another example. Some of you complained yesterday that I'm too fast, that most of you are writing. So please, you can take out time. I'm giving you just 1 minute to write. 1 minute to write. Please, if you are following, indicate that you are following. Okay, next question. Before we go into the next question, I said I'm going to explain complement, right? Complements of a set. Sorry, I omitted this. When you do a complement of a set, let's say of set A, this simply means what? A prime, abi, or A complement, this way. When you see anything like this in set, it means A complement or A prime. A complement means these are elements that are found in the general set, but not in the main subset A. Complement of A means element found in the general set, but not in set A. Like, let's say, for example, if general set is given as 1, 2, 3, 4, dot, dot, dot to 10, and set A is a set of all even numbers, 2, 4, 6, 8, and 10, then we are asked to find A complements. What are the elements that are found in the general set, but not in A? They are just 1, 3, 5, 7, 9, right? Meaning that elements found in general set, not in set A, are 1, 3, 5, 7, 9. So this is all about complement of the set. Now let's solve one of the first question here. The question here says that let A equals to 2, 3, 4 sets 1 and 5. Okay? And B is 1, 2, 3, and set 3. Then C is 0, 2, 4, and 6. Then we have to tabulate number 1, A union B. Number 2, B union C. Number 3, A intersection B. Number 4, C difference B. Number 5, B difference C. Number 6, A difference B union B difference C. Union B difference what? C. All right, let's solve this together. These are very simple questions. Solution. Please, if you are online, indicate that you're online. If you're online, indicate that you're online. Let's proceed together. If you are watching, indicate that you are watching. If you're online, indicate. Let's solve this problem. Please, guys, do me a favor now. Share the group link now. Share the group link to your departmental platform. Tell them that we are live. We are live. We are solving into past questions in mathematics. Tell them that we are live now. Let them join. Share it now. Please, if you have shared the group link, if you have shared the link rather, the YouTube link, indicate that you have shared it in the comment section. Please indicate. Share it. Please share. Just go off a little and share. Please share. Share. Okay, let's look at this question we have here. This is a very simple question. Here we have set A, set B, and set C. Look at it. We have set A is given as 2, 3, 4. Then a set inside set A. Set B is what? 1, 2, 3. And that set 3. Inside what? Set B. Then the same thing with set C. We have 0, then set what? 2, 4, 6. You have to take note that a set found inside another set represents an element of that set. Set inside another set represents what? An element of what? And of that set. That means that if you look at set A, what if we have to find the number of elements in A, or the cardinality of what? Of set A is simply 1, 2, 3, and what? 4. Set A has 4 elements because why? These sets 1 and 5 located inside set A is treated as one element. Are you guys following? As one element. So here we have 1, 2, 3, and 4. For set B, number of elements in B is the same thing, which is 1, 2, 3, and what again? 4. 3, element 3, and this are not the same. This is a set located inside what? Another set. So the number of elements in B is 4. Number of elements in set C, what will it be? It's 2. We have 0 as one element. Then set 2, 4, 6 as what? The second element. So the answer is what? Is 2. Don't forget that a set found inside another set represents an element of what? Of that set. Now you can then find their union. You can find their union and some other properties we are asked to calculate. Okay, let me clean this so we can solve together. The first question says we should find A union what? B. A union B simply means combining A and B together without repeating any elements. Let's combine and see. If we are to combine, that will give us what? I'll start with 1, right? We have 1 here, followed by what? 2, followed by what? 3. We have 1, we have 2, we have 3. I've only picked 2 and 3, so I will not repeat them again, right? We are looking at A union B between these two. We have 1, 2, 3, followed by 4. After 4, what follows 4 is what? Is set what? 1 and 5. Please pay attention. We picked 1, 2, 3, and what? 4, right? Then after 4 follows what? Sets. 1, comma what? 5. Comma. Then followed by what? What is the next one here? Set what? Set 3. This is the result here. This is our A union B. We have 1, 2, 3. Union means combine, but don't repeat any element. So we have 1, 2, 3 already out. Then we have 2, 3. I will not repeat them again. So the only element I've not indicated is what? Element 4, which is this Abi. Then followed by what? Set 1 and 5, and set what? Set 3. What's the next one here? Number 2 is B union C. B union C means combining B and what? C together without repeating any elements. So what we do first is to pick element 0, right? Followed by 1, 2, 3. 1, 2, 3. Then after 3, what follows 3 is what? Is set 3. We have set 3. Then followed by the next one is what? 2, 4, and 6. Is 2, 4, and 6. Final answer. Always look out for what follows an element. For A intersection B, we started with the list 1, 2, 3. We now pick what? 4. What follows 4 is what? Set 1 and 5. Then you pick set 3, right? Then for B union C, we pick what? For 0. Followed by what? 1, 2, 3. Right? What follows 3 is what? Set 3. Then followed by what? 2, 4, and 6. Just like that, right? The next one is number 3, which is A intersection B. Meaning between A and B, what is common? The first one is 2. We have 2 here, we have 2 here. Right? We have 3 here, we have 3 here. What again is common? Nothing is common. Please, 1 is not common here. These two elements in a set are taken as a single element. So I cannot say 1 is common. No. So what is common between them is what? It's just only 2 and 3. 2, 3, 2, 3. Okay? Suppose we have this set 1 and 5 here, also here. So I'll bring it out as common elements. But since we only have it here, and it's not here, so the only common element is what? Just 2 and 1, 3. If you are understanding what I'm saying, please say I am following. If you understand what I'm saying, please say I am following. If you are getting it, say I am following. Okay. Someone is asking a question. Let me just answer that question now. The person said in the comment section, if we are to find the subset of B, how do we do that? Very simple. From the power set of a set that shows the number of subsets, right, in a given set, subset of B can be gotten from the power set of what? B. Formula says 2 raised to power n. Here n is equals to what? It equals to 4. Our n is 4. 1, 2, 3, and 4, right? 1, 2, 3, and 4. Okay. So yeah, that will give us P of B equals 2 raised to power what? 4, right? And 2 raised to power 4 is same as 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 will give us about 16. Wow, 16 subsets. 16 subsets, right? Then the first element, the first subset of any set is an empty set, right? Let me see how I can answer this question. But okay, that's all I'm doing. To find the subset of a given set, it means I have to use the power set formula that says what? P of B equals 2 raised by n. In this case, our n is 4 because we have 1, 2, 3, and 4. Now let's take this out. The first element, the first subset is an empty set. Followed by what? The single set, Abi. We have set 1, we have set 2, we have set 3, we have set, the next one is what? Set of set 3. Are you guys following? Empty sets. We have set 1, Abi, set 2, set 3, then set of what? Set 3. Are you seeing where I place it here? Then comma, followed by what? 1, 2, 1, 3, right? 1, 2, set 1, 2, set 1, 3, set 1, 2, set 1, 3, set 1, 3, set 1, comma, set what? 3, right? Set 1, comma, set 3, which is 1, 3, Abi, 1 and this set. What we did first was to bring out what? The empty set. Set 1, set 2, set 3. Then we will now come with what? Set 1, 2, set 1, 3, set 1, comma, set 3, right? Now the next is to look out for set 2 and set what? This, right? We have done set 1, 2, set 1, 3, set 1 of this set. Then the next is to start with what? 2. So we have what here? Let's go. We have 2, comma what? 2, comma 3. We have 2, comma set 3, right? Then the next is set 3, comma set 3. 3, comma what? Set 3. We have done, let's repeat again. We have done 1, 2, 1, 3, and 1 set, and 1 set 3. We have done 2, 3, right? We have done 2 set 3, right? Is that clear? Now let's look at what? 3 and what? Set 3. 3 and set 3. Okay. 3 and set 3. Okay. Then the next is to, let's see if we have exhausted a single set, right? We have done 1, 2, 1, 3, 1 this, 2, 3, 2 this, 3, and 3 and what? Set 3. Now let's go into triple set, right? Triple set. 1, 2, 3. 1, 2, 3. Followed by 1, 3, and set 3. 1, 3, and set 3. Right? Okay. Let me clean a little bit. Let me clean one of this part here. We have already learned this. We have seen 1, 2, 3. 1, 2, 1, 2, 3. 1, 2. Sorry. So 1, 2, and set 3. 1, 2, 3 is out. 1, 2, 3 is out. Then we have 1, 3, and set 3. But we don't have 1, 2, and set 3. That would have been the first. 1, 2 first. We have 1, 2, 3. 1, 2, and set 3. Then 2, 3, and set 3. 2, 3, and what? Set 3. Right? Okay, let's check again. Let's take 1, 3, and set 3. 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 Let's count. Let's know what we have already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then the next one will not be what? The entire set, Abi, which is 1, 2, 3, and what? Set 3. So this is the solution here, right? For the person that asked this question, what are the subsets of what? Set B. These are the subset of set B. Please take notes. All right? Now let's proceed now. We have done A union B. We have seen B union C. Right? And we have seen A intersection B. A intersection B. Let me repeat that again. A intersection B. For A intersection B, between A and B, what is their intersection? What is common between them? It's just 2 and 3, right? 2 and 3. I think we have done it before. Now the next is to find C difference B. IV. C difference what? B. What is C difference B? Don't forget I say that this difference means elements that are found in C but not in what? In B. Element found in C but not in B. Let's see. Element found in C but not in B. The answer is simply in C but not in B. It's just 0, right? We have 0 in C but it's not in B. And we also have 2, 4, and 6 in C but not in B. So that means the answer is simply what? Set C, which is what? 0, what? Set 2, 4, and what? And 6. C difference B means those elements that are found in C but are not in B. 0 and these elements, they are in C but not in B. So the result remains what? The same as set what? Set C, right? Now let's finish up. I hope you have taken note of this, right? Okay. Let's finish up what we have. Let's go. B. B difference C. What is B difference C? Those elements found in B but not in what? In C. Okay. It's simply, they are what? 1, 2, 3, and what? Set. And set what? 3. All these elements are in B, but they are not found where? In set C. So the result is still what? 1, 2, 3, and set what? 3. Number 6. Says A difference B union what? B difference what? C. Already we have gotten our B difference C as this, Abi, but we don't have A difference B, right? This sign means A difference, means element found in A, but not in what? B. Let's take note that, or let's find A difference B, right? What are A difference B? Element found in A, but not in B. Let's check this out. We have 2 here, we have 2. 2 is not part. We have 3, we have 3. 3 is not part, right? We have 4, but there's no 4 here, so 4 is part. Followed by what? This, Abi? This set here is in A, but not in what? In B. So we have 1, what? 5. Then we call that B difference C. We have already saw this as what? 1, 2, right? 3. And what, yeah? And set 3, right? We already have this as this. We have gotten our A difference B as 4, what? 1, 5. But we are also find their union. Therefore, A difference B. Therefore, A difference B, union what? B difference A is simply the union of this and this. Let's go. What do we have? Union of this and this. I'll pick what first? 1, 2, 3, right? We have 1, 2, 3. Followed by what? 4. Followed by what? Set 1, what? 5. Abi? Then followed by what? Yeah? Set what? Set 3. I repeat again. A difference B means element found in A but not in B, right? Which are 4 and this. Is that clear? Then already we have already solved for B difference what? C. Element found in B but not in what is C. I mean the entire value of what? Of B. But to find their union between these two, union means I'm going to combine them, right? So I'll start with the least element, which is what? 1, 2, 3, followed by 4. What follows after 4 is what? Is set what? 1 and 5. Then followed by set what? 3. That is just all about this. There's nothing much about this. Okay? Let's solve more examples. Please, you can write, okay? You can write while I bring out more examples for us to look at. All right, let's look at this. We are given a set. Given a set. General set equals x such that 0 is less than or equals to x, less than or equals to 20. Set A is given as 1, 3, 5, 6, 8, 10, 16, 18, and 20. Set B is 1, 2, 4, 5, 7, 9, and 11. We are now told that where A is a subset of universal sets, and B is also a subset of what? Universal sets. Then obtain number 1, A intersection B. Number 2, A difference B. Number 3, B difference A. Number 4, A complements union B complements. Number 5, universal sets difference A complements union B complements. If we are given this to solve, this is very simple. First of all, general set is represented using set builders, right? That s is so that 0 is less than or equals to s, less than or equals to 20. So the first thing you need to do is to interpret this, right? Either is to interpret this. All right. Then before we start solving, our general set, let's interpret general set first. General set is we are told that x is so that 0 is less than or equals to what? X. The word less than or equals to simply means 0 is involved. If 0 is less than or equals to x, that means x is greater than or equals to your 0. I repeat again. If we are told that 0 is less than or equals to x, that also means that x is greater than or equals to what? 0. And that same x is less than or equals to what? 20. Meaning that if we are saying that x is greater than or equals to 0, what are the numbers x is greater than or equals to? That means from 0 itself, right? So this means from 0, followed by what? 1, 2, 3, 4, 5, down to what? To 20. Why do we have to involve 0? Because we are told that 0 is less than or equal to. There is an equal sign here. If there is no equal sign, that means I will start from 1. But because I have an equal sign here, I have to start from 0. And the reason why I have to end at 20 because I have an equal sign. If there's no equal sign here, that means I will end at what? 19. So for this, we have less than or equal to 20. So I have to stop at 20. So already we have seen that set A is given, set B is given. We are not told that A is a subset of universal set. I explain what this means. That either A is equals to what? General set, or A is not equal to general set. That means every element in A are contained in what? In the general set. B is a subset of general set, means every element in B are contained in what? In general set. That means that general set is simply a superset Please, if you are following, indicate that you are following. Indicate that you are following. If you are following, indicate that you are following. Please indicate that you are following. Please, are you guys following? I see following, indicate. Please, if you are following, indicate that you are following. If you are with us, please indicate that you are still with us. Let's talk about Venn diagram. What is Venn diagram? Venn diagram is not like using um, diagram to represent different subsets. Okay, it is a representation of what of sets using a diagram, either that shows how two or more subsets are what are related or are connected. Okay, Venn diagram shows relationship that exists between two sets or three subsets or more than three subsets. But in general terms, it shows relationship. It shows relationship between sets. Either. Now, the first I want us to look at is between two sets. Between two sets, right? If I have a diagram like this, we are asked to represent the intersection of this set. Let's say I have set A and set B, and this part of set is the shaded part. What do we call this? This is called A intersection what? B, right? This is called what? A intersection B. Okay? If I have another diagram, let's say we have this and we have this, and this is the shaded part, all right? And the shaded part is every part here of A and B are both shaded together. Okay, I will not jump up, I'll just give us a little diagram. Then we'll go into your past questions and solve some problems. Okay, this represents what? A union what? B. This first one shows what is common in A and in B, right? This other one shows the union of what? Of both A and what? And B. All right, now let's see another aspect. Let's say we are giving a diagram like this. Let me take off this center one. Let's say we have this, and the shaded part is just this part here, just the outside is the shaded part. What do we call this in sets? This is called A union what? B, all what? All prime. This shows all the elements that are found in the general sets, but not in what? In A union B. Element found in the general sets, but not in A union B. That is what we call this, right? Now, what if I have a single set? Let's say I have a single set, just a single set in a Venn diagram, just like this, set A, either, and this part is the shaded part, inside is the shaded part. What we call this? This represents set what? Just set A. This means this set A means all the elements that are contained in set what? In set A. What if we have this? Let's say we have kind of diagram, and The shaded part is inside the Venn diagram, not in any part of A. So what do we call this? This simply means what? A complement, right? Or A what? A prime. It shows all the elements that are found in the general set, but not in A. A is empty, but not in what? In A. Let's look at something else entirely. If we have a diagram like this, if I have something of this nature, let's say I have set A and set B, and this part is the shaded part. In sets, in Venn diagram, we call this A only, right? This means A what? A only. A only. And how do we interpret this? This simply means what? A intersection what? B prime or B complement. Or this also means A difference what? B. Or this also means what? A slash what? B. This set shows element found only in what? In A, but not in what? In B. And every part of B is empty. So we call this what? A difference B. Or A slash what? B. Or A intersection what? B what? Complement or B prime. Are you there? This is how simple this can be. Please, please, I'm coming. Just give me some few minutes. Let me change over, okay? This is my house. We just have lights now. Just give me some time to change over, okay? Few minutes, I will come back, then we'll continue. Just 2 minutes. Thank you. Hello guys, so sorry for that. So sorry for that. So sorry for that interruption. I'm so sorry. Just wanted to make sure that uh, class is not being interrupted. All right, guys. Are you guys understanding? Okay, someone said I'm understanding bit by bit. Please, if you are following, please indicate that you are following. If you are following, please indicate that you are following. So we can continue. We can keep on pushing. All right. Okay. I want us to look at another kind of diagram. What if we have a diagram like this? A diagram like this. Something of this nature. Let's say we have here is A and here is B. And the shaded part is just this part here. How do we interpret this diagram? You notice that only A, set A is empty. So this simply means A complement or A prime intersection what? B, right? Or we can say that B intersection what? A prime. It simply means B difference A or B slash what? Slash A. This shows elements that are found only in B but not in what? A. And that word for this is called what? B what? B only. B only. In set interpretation, it's called B only, right? All right, let's look at something else entirely. I'm going to use your workbook to solve more examples, there's a workbook some of you came with at the tutorial center. I want us to solve some problems from the workbook so we can have a proper understanding of what set is all about, right? So let's look at this workbook together. Please, if you are with me, say I'm with you, sir. Please, if you are with us, just indicate that you are with us. Let us know those who are online. Okay, the question says that use Venn diagram to illustrate the information below. Okay, before we do that, I think there's something I'm missing. I've not showed us if we have 3 subsets, right? There are many diagrams. I'm going to be using past questions to explain them under Venn diagram. If I have 3 subsets, sorry for that. Let's say we have this, I have this, I have this, and I have this. This subset A, subset B, and subset C. And the shaded part is their midpoint, this center here. Okay, this simply means what? A intersection would B intersection C, right? If I have something of this nature, we have this, and we have this. And here we have A, we have B, and we have C, right? And let's say every part of this is a shaded part. Is a shaded part. What does that mean? It simply means A union what? B union C. All right. The first one shows what is common in A, B, and C. Right. What the second diagram shows what? Union of what? Of A, B, and what? And C. What if I have a diagram like this? A diagram like this. Let's say we have this, and we have this. And the shaded region is simply this. Let's say we have this shaded region. Okay. Then this part is also shaded. All right. Now, how do we interpret it? We notice here is set A, set B, and set C, right? So this is, look at this, only B is empty. So that means our A intersection B prime intersection C, right? A intersection B prime intersection was C. This is how we can represent such kind of what? Of sets, right? Such kind of sets. Okay. Now let's look at something else entirely. Then other ones, I'm going to use diagram, ask questions rather, to explain them, right? To explain them. Then the next one I want us to look at is your workbook. Your workbook or your past question. This question says that use Venn diagram to illustrate the information below. We are told that general set is given as set 1, 2, 3, 4, 5, 6, 7, 8, 9, and what? And 10. Subset P is given as 2, 4, 5, and 7. Subset Q is given as 1, 2, 5, 6, and 8. Subset R is given as 1, 2, 4, 6, 9. 1, 2, 4, 6, and 9. Then we have to represent this in a Venn diagram. Okay, this is one of your questions. So let's see how we can represent this together using a Venn diagram. So what we need to do is to bring out our Venn diagram. We have a general set here that shows from 1 to 10. Okay, then we have the various subsets. Subsets mean P is a subset of general set, Q is a subset of general set, even R is a subset of general set. So I'll bring out the 3 subsets, 1, 2, and what? And 3. We have P, we have Q, and we have what? R. The first thing we need to do is to look at what is common between P, Q, and R. Look at, we have 2, 4, 5, 7. We have 1, 2, 5, 6, 8. We have 1, 2, 4, 6, and 9. So between these three subsets, what is common is 2, right? It's 2. We have 2, we have 2, we have 2. We have 4, we don't have 4. There's 4. We have 5, we have 5, there's no 5. We have 7, there's no 7. So the common element here is what? It's just 2. So that 2 will be at the middle. This middle shows what is common between P, Q, and R. It shows P intersection Q intersection R, which is equal to what? 2. Now the next one is to bring out the exactly 2 sets. P intersection Q is here. This means exactly 2, exactly 2, exactly 2. This space here is for P intersection R. This space here is for P intersection Q. While this other space is for Q intersection R. Then I'll check between P and Q. What is the intersection? What is common between them? Apart from these two, what is common between P and Q? Between P and Q, let's find out. Already we have 2, Abi. 2 is already half, so I will not repeat 2 again. I will now look at other number. Is 4 is here, 4 is not here. 5 is here, 5 is here. 7 is here, 7 is not here. So the P intersection Q is simply what? 5, right? It's 5. So I'll put the 5 here. Then the next is to take between P and R. Let's take between P and R. We have 2, we have 2. 2 is already out. I will not repeat 2 again. We have 4, we have 4. So I'll bring out 4. Let's check the other numbers. We have 5, there is no 5. We have 7, there is no 7. So the result here is just only 4. Now let's go. The next is to bring out what is common between Q and R. Between Q and R. Let's take this R between Q and R. Let's go. We have 1. We have 1, right? 1 is common. We also have 2. We have 2. But already we have already brought out 2, so I will not repeat that again. Let's take 5. 5 is here. 5 is not here. We have 6. We have 6, right? Okay, that means also we also have what here? 6. Let's take other ones. We have 8. There's no 8. So between Q and R, the intersection is just only Q and the R. This is Q and R only. This part here means P and Q only. P and Q only. P and R here means what? P and R only. This part here means what? Q and R only. Okay? Alright, so let's move on. Let's move on. Now we have brought out all their intersections. The next is to bring out P only, Q only, and R only. If P is saying 2, 4, 5, 7, and already this is the space for P, Abi. This cycle here represents subset for P. That means we have only brought out 2, 4, and 5. 2, 4, and 5. So what's many years what in P is 7. So this 7 now completes all the subset of P, which is what? 2, 4, 5, and 7. Exactly. Now the next is to look at Q. If the Q here we have here is just only 1, 2, 6, 5, or 1, 2, 5, 6, 1, 2, 5, 6. So the next is to bring out the remaining one, which is what? 8. So this 8 completes all the subset of what? Q, which are what? 1, 2, 6, and 5. The next is that of R, right? That of R. What we have here for R is simply 1, 2, 4, 6. 1, 2, 4, 6. So if I have 1, 2, 4, 6, the remaining number will be what? 9. So this 9 is what completes the subset of what? Of R to be 1, 2, 4, 6, and 9, right? Now, after doing this, now look at the general set. General set is 1 to 10. 1 to 10, right? Because we have to represent all the elements that are in this set using a Venn diagram, right? We have already captured 1, 2. We don't have, there's 3 in the general set, Abi. 3 is in general set. So other ones will be outside. We can have our 3 here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. The next one is 10. I can even put the 10 here, showing that it is not part of the subset. They are just part of the general set. They can be found anywhere outside the set. So this is the answer to this question. Okay, let's move on to the next question. Please, if you are following me, please indicate that you are following. If you are following, please indicate that you are following. If you are following, please indicate that you are following, because this class will continue until we have exhausted everything we need to learn. Are we there? Please, guys, let's share the group, the link again. Let's share the link. Let's share the link. Please share the link to your classmates. If you share the link, say I've shared the link. Please don't just be online and be learning alone. There are people who need to be part of this class. Let's try and reach out to them, please. Let's try and reach out to them, please. Let's reach out to them. Let's reach out to them. Please share the group link to as many who can join us tonight. Please share, please share, please share. Already we only have 58 views of people who are online, who have seen our video. So please share to other people. Let them partake. Please share. If you have shared, say yes, I've shared. Please refer the group, the link. Just share it to your WhatsApp platform. Share. While I wait, I'm waiting for you to tell me that you have shared it. I'm still waiting for you to tell me that you have shared it. Please, if you have shared, please indicate that you have shared. Okay, the next question, we have here. The next question. The next one. Let's share. Please, if you have shared, and you are active, please indicate that you have shared and that you are active. Okay, please, guys, have you guys shared so we can continue from where we stop? Okay, let's see how far we can go. All right, guys, so let's continue from where we stopped so we can look at other aspects. The next question here says, in each of the Venn diagram below, shade I, shade the first one, shade the question 1 says A intersection B union C. Okay, I says A union B intersection C. I says A difference B union what? C. In each of these, and the first diagram we are given is this diagram, where we have here as A, here as B, and here as C. Then the second one is, okay, let me bring it out here. The second diagram is this. We have another set. Then we have the third set this way. Here we have set A, set B, and set what? C. Alright? Okay, this class might be ending very soon because of my battery capacity. And I hope you guys are following, please. I hope you are following. Now let's look at this question together, then we can know how far. We are told that in each of the Venn diagram below, shade A intersection B union was C. Okay, this question came out, I think, in your manual, and they might repeat this in your exam. I hope you are aware. So let's see how we can solve this together, right? How do we solve this together? All right, so this is one of the most simplest questions you can ever see in the exam. It's one of the most simplest question. Okay, let's look at the first one. Look at this very well. The first one, we have to find A intersection B union C. Which of these parts are we going to shade to indicate this, to show us this? Now, how the best way I can explain this is this. I have to bring out this set into 2. I'll bring it out this way. Bring it out this way. We have A, we have B, and we have what here? C. Then also bring out another duplicate of it this way, and this way. We have A, we have B, and we have what? C. Here we are connecting, we are relating two things together. We are relating A and what? B union C together. Then if I can be able to get, I will use this first one to represent A. Then use this to represent what? B union C. Then we cannot find the intersection. This symbol here means what? Intersection. It means what is common in A and also in what? B union C. Now, the first is that, what does this A represent? Let me use this to represent A. If I'm to find set A, this is set A. It means I will shade every part of what? Of A, right? Okay. Just follow up this class. This is set A. Now the next is to bring out what? B union C. I'll use this to bring out B union C. B union C means I'm shading every part of what? B. Every part of B and every part of what? C. So this diagram represents A. This represents what? B union C. Right? Are you guys following? Now I'm looking for their intersection. The question now is this: where is A and B union C intersecting together? Where are they intersecting? That's the question. Now look at this here. They are not intersecting here because there is empty. If you look at this, this part of A is shaded, right? But this part of A is not shaded. Number 2 is that they are not intersecting here because here is empty, this part is shaded. Number 3 is that they're also not intersecting here because here is empty, this part is shaded. Now, where exactly are they intersecting? Number 1, They are intersecting here. This part is shaded. This is also shaded, right? Look at this. This is also shaded. So I'll shade here first. Okay. Then followed by this part is shaded. This is also shaded. I will call it shade here. Right? Their intersection here is the middle part is also shaded. Likewise, here is also shaded. Means I also shade here. Okay, this is just the final result here. Okay, let's take this. This part is not shaded. This part is shaded, so it's not an intersection. So the only intersection we have is just this, this, and this, which is this. So this represents A intersection what B union C. So the result of the first one, please look at it very well, is simply this, right? It's simply this. From what I've explained so far, it's simply this. It's simply what is common in A and B union C, which is this my A, this my B, and this my C, which is this region and this region, right? So this is my result here. Okay, so let me take off this again so I can solve for other ones. All right? Okay, so please look at this question and tell me what you feel in the comment section. Tell me what you feel in the comment section. Tell me what you feel in the comment section. Okay? Are you following? If you are following, please indicate that you are following in the comment section. Please indicate that you are following in the comment section. Please indicate that you are following in the comment section. All right, we are rounding up now with this question. Now the next one says, find A union B intersection what? C. Let's find A union B intersection C. With this same diagram, A union B intersection C. Number 2, A union B intersection C. Now how do we do this? This is very simple. A union B intersection C. Look at this diagram here. Let's bring it out. Let's bring this out. Let's bring this out. Here we have A, we have B, and we have what? And we have C, right? Okay. Now, this part here is showing A, right? This is my A. Are you there? Union B intersection C. What is our B intersection C? This is my B intersection C. Look at this here. From here to here, this part here, this part, and this part are intersecting where? Here and here, right? Are you there? Am I communicating here? The way we solve for this is not the same way we solve for this. I'm bringing out their union. The first is to bring out the union. What is common between is like bringing together A and what? B intersection C together. Now the first is to find out what is B intersection C. Where can we locate B intersection C? It's simply here and here. This is my B intersection C. So that means that I'm going to shade here first, my B intersection C. Then union A. Where is my union A? Is here. This is my union A. This is the result here. This is the result here. All right. So this is my result. Very simple. All right. Now, why am I not involving this part here? Because this part shows A intersection what B. What I'm combining is what? B intersection C, which is this B and B intersection C. This region already. If you look at this, let me show us something. From this diagram here, what is our B intersection C? This is my B, Abi, right? This is my B and this is my C. So they are intersecting in these two places. Then I will shade these two, this and this. Then shade every part of A, right? Every part of A. I will shade here, then shade every part of A, leaving behind this. So this is my result for this question. Hope it's clear, somebody. If it's clear, If it's not clear, please indicate that it is not clear so I can explain. Please indicate in the comment section. Indicate in the comment section. Indicate in the comment section. The next question. The next question. The next question. Please indicate in the comment section if it's not clear. Indicate in the comment section if it's not clear. Indicate in the comment section if it's not clear. Look at this question. Let's look at this question again, please. We have seen this, Abby. We're looking at A union. Sorry, this part is meant to be shaded because it's still part of A. It's still part of A. Sorry. We are meant to shade every part of A with the intersection of what? Of B and C. This part of A with the intersection. Please take notes, please. We are looking at A, right? A union. This is not A intersection, it's A union. It means that I will bring out every part of this A, right? Then union B intersection what? C, which is this part. So we are shading here, also shading here. Then we are leaving this space empty with this space what? Empty. The next question, the next one is simply A difference B union what? C. A difference B union C. Please, if you have any question, you can ask from the comment section. You can always ask me in the comment section. Please ask, please ask, please ask. If you have any question, you can ask from the comment section. If you are following, please indicate that I'm following. Now, the next one, the third one, is for this same diagram because we want to solve this, and this with this diagram, right? So let's look at the third one. The third one says, how do we represent this? A, B, and C, which is A difference B union what? C. A difference B union C. This sign means difference, means elements that are found in A, but not in B union C. Element found in A, but not in B union C. Meaning, I'm going to shade all the elements in A, excluding B union C. What is B union C here? This is my B union C, right? B union C means I'm combining both B and C together. So A difference B union C is simply this region here. I'm going to shade this region. This shows all the elements that are found in what? In A, right? In A, but not in what? B union what? C. That is what this diagram is representing. Are you there? Now the next is to represent all of this using this set here, this Venn diagram. We are given two sets. We have been able to see how we can represent all of this using this diagram. And let's look at how we can represent all of this using this kind of diagram. Are we there? Okay. So let me just clean up this so that we can have a white space to solve the problem. Now the other diagram is like this, right? It's like this. We have A, we have B, and we have our C here. Now let's represent the first one. The first question here says A intersection B union or C, right? A intersection B union C. Please, if you're online, please indicate that you're online. If you're online, if you are still following us, please indicate that you are following. We're almost rounding up with this. Now look at this here. Like we did in the first example, I'll bring up two separate diagrams showing this. I have A, I have B, right? Then we have C. Okay? Then I also bring out another diagram. We have our A, we have our A, we have our B, and we have what? Our C. We have A, we have B, and we have C. The first is to shade every part. We are looking for the result, right? I will use this as as a template for the results. The first is to bring out A. Every element, all of these are what are A. If you look at this, B is inside of A, right? That means B is a subset of A. So to bring out A first, I will shade every part of A, right? Every part of A is being shaded. Then I'll also bring out what? B union C. What is B union C? Meaning combining B and C. This is my B, right? And this is my C. So the next is to bring out their intersection, meaning between A and B union C, what is common? Where can we find the common elements? Look at this here. Let's analyze together. Here we have A, right? Here we have B union C. So that means that they are not common here, right? Because here is not shaded, here is shaded, right? But they are common here. They are also common here. They are also common here, but they are not common here. So that means that I'm going to shade this part, and this part, right? I repeat again. I will shade this part, I will shade this part, and this part. So the result here is simply this here, we shade here, and also extend the shading to this side. Are you guys following? So this is simply A intersection B union what C, right? This is simply A intersection B union C, because they are not intersecting here. Around the ring, they are not intersecting here. This is empty. This part is shaded, right? Look at this part. This is also not shaded. This is shaded. So I will leave here. I will in the answer. We'll leave here empty because there's no intersection here. We also leave here empty, right? Because there's no intersection. They're not intersecting at the edge. Also not intersecting here. So the intersecting is simply the entire value of B and this.
Sorry guys, I had a little low battery. Please, are you guys active? Are you guys active? Are you hearing me? Are you guys active? Please, if you're active, indicate that you're active. Please, if you're active, indicate that you are active. Please, if you're active, indicate that you are active. Please, if you're active, indicate. Now, the second part I want us to look at is this Abi. We have seen A intersection B union C. I'm so sorry for that. My phone battery was so low. I needed to plug it so that I can be able to finish up with this. All right. Okay. So the second part says A union B intersection C. A union B intersection C. Meaning we are combining all of A and what? All of what? B intersection C together. Now look at this first. If we are, let's bring out what is B intersection C from this diagram. Is simply every part that connects what? B and C are B. This circle here is for C. This is for what? Also for C. So we have for C and for B, right? So that means our B intersection C is simply this region here. So the first is to bring out what? B intersection C, which we have just done, right? This is our B intersection C. But the question says A union, meaning I'm combining the entire value of A with what? B intersection C. That means I'm going to shape every part of A as well. Every part of A as well. Every part of A as well. So this is the region here that indicates A union B intersection what? C. This is how simple this can be. Then the next question says A difference B union C. A difference B union C. Let's solve for the third one. A difference what? B union C. Let's bring at the diagram we have. This is our set A. We have our set B. This set A, this set B. Then we have set C, which is this, right? So we are looking at we are bringing out A difference B union C, meaning elements that are found in what? In A, but not in B union C. Not in B union C. Meaning I've already shaded every part of A, but excluding what? B union C. This is my B here. This is my C here. So I'm going to exclude this part, right? So the only part that will be shaded is just this part here. Just this ring part, right? The ring part, this part. This shows elements that are found in A, but not in B union C. If you look at this now, not in B union C means only B union C is kept empty. It's kept empty. So this is the required region we are looking for, which shows elements that are found in A, but not in B union C. This part shows elements found in A, but not in B union C. I hope you are following, right? I hope you are following. Please, if you are following, say it, I am following. If you are following, say it, I'm following. Okay, if you are active, please indicate that you are active. Indicate that you are active so we can conclude on this. Okay, I think I'm going to stop here for now because my battery is very low. So tomorrow I will prepare ahead of time so that I will have a strong battery. I'll prepare for this class tomorrow because my battery is very low. There's a lot for us to discuss about, right? So tomorrow we'll look at mapping function tomorrow. Look at mapping function tomorrow. Mapping function tomorrow. Then we also look at word problem in set theory. In set theory. Then we also look at analytical proofs of sets. Analytical proofs of what? Of sets. Then we look at the laws of sets. Laws of sets, right? Laws of sets or laws in set theory. Then under mapping function, we'll look at the types of mapping. Types of mapping. We'll look at what we call range of function. We'll look at the difference between mapping functions and set theory. Then we'll also look at different relations, types of relations, and all that. So many things we'll be discussing tomorrow. Then under the types of mapping, we'll look at injective, we look at surjective mapping function, we'll look at bijective mapping function, also look at constant mapping function, also look at what we call one-to-many functions and inverse function. Then also look at composite function. All of this we'll be discussing tomorrow. Okay, tomorrow I will conclude on set theory and mapping function tomorrow. So make sure you guys come online tomorrow. The same time, we'll be starting on time tomorrow by 7 p.m. tomorrow. Then the class will end by 9 p.m. tomorrow. All right, 9 p.m. tomorrow. Please, for those of you who just joined us, who just came online, this class has been on since 7 p.m. Make sure you go through all the classes. We have laid the foundations already on set theory. We have seen the types of sets. We have seen the properties of sets. We have solved some problems in sets already. We have seen the difference between subset and proper subset, and super subset and super proper set. All of this we have discussed so far. Then we have also seen the a way of interpreting Venn diagram. Okay, we have seen how to interpret Venn diagram, and we have been able to solve some problems even representing subsets in a Venn diagram. So tomorrow we'll continue. Tomorrow will just be a direct class. I will just start solving and start teaching and all that, because today is just to lay the foundation for this course. All right. Then tomorrow I will emphasize more on mapping functions, which is a means of assigning some elements of a particular set with other elements in other sets. All right, we shall look at the different types of mapping functions and all that. So see you guys tomorrow, the same time, 7 p.m. All right, but if you have any question you want to ask, you can drop that question in the comment section. Second, again, if you have any topic you know that you're having challenge with and you would love us to treat, indicate them in the comment section. If there's any topic you're having challenge with, maybe in mathematics, maybe mathematical induction, GCD, or anything AP and GP, just indicate them. Then in physics, the same thing. Any challenge you are having, just indicate those challenge. Then I will look at them for us to discuss about it. Definitely, I will talk about them in the class. So see you guys tomorrow. Thank you. And for those of you who attends my tutorial at IMSU, I'm meeting tomorrow morning by 7 a.m. 7:30 rather, be there, because the class will start by 7:30 and it must end by 10 a.m., which is our chemistry class. Then from 10 a.m. we proceed to 1 p.m. for physics 101. All right. So see you guys tomorrow. Thank you so much. Good night all.